Draw lines M and N, they appear to be parallel, and draw a line L that's intersecting both of them. Label the 8 angles as I have them labeled here. It'll make it a lot easier to talk about the things we need to talk about today if we have those labeled. Okay. Corresponding angles. A pair of angles that are in the same position. These are not the definitions you're going to find in the book. These are my definitions. I use words that I think that are easier for you to remember and understand. And they're also the cue words I'll give you when you get confused. So, same position. We need to think about corresponding as in the same position. When we were talking about reflections in Unit 1, we talked about reflections, and we said the corresponding parts of one of you and your image, okay, they're in the same position. So in this intersection up here, oh my goodness, sorry. Forgot what I was doing. In this intersection up here, what angle's in the top left position? Angle 1. So in this intersection down here, what angle's in the same position? 5. Angle 5. So angle 1 and angle 5 are called corresponding angles. They're in the same position from one intersection as the other angle is in the other intersection. So what angle corresponds with angle 7? Angle 3. What angle corresponds with angle 2? Angle 6. And what angle corresponds to angle 4? Angle 8. Corresponding angles in the same position. Okay? Any questions on that? All right. So moving down a little bit, we're going to talk about alternate interior angles. So the words I want you to remember and understand in alternate interior angles are opposite side of the transversal, inside the parallel lines, and at opposite intersections. So they have to be inside the parallel lines, they have to be opposite sides of the transversal, and they have to be at opposite intersections. Looking back at our picture, alternate interior angles, opposite sides of the transversal. So name a pair of angles. So name 2 angles on opposite sides. First of all, L is our transversal. We haven't officially identified that yet. This is a transversal. We'll talk about what that is in just a second. Transversal. That's this one. Very good. Okay. So name a pair of angles. Raise your hand, please. Name a pair of angles that's on opposite sides of the transversal. 2 and 5. Okay? Good. 2 and 5 are on opposite sides of the transversal, aren't they? Okay? Name another pair of angles that's opposite sides. Yeah. 5 and 6 are on opposite sides of the transversal. Name another pair of angles that are on opposite sides. Brad?
7 and 1.
7 and 1. Okay? Opposite sides of the transversal. Are we okay with what that means now? Okay. Let's move on now and say name a pair of angles that's inside the parallel lines. If M and N were our parallel lines, name a pair of angles that's inside them. 4 and 5. 4 and 6. 3 and 5. 3 and 6. 5 and 6 are inside, aren't they? Okay. Now, let's name a pair of angles that's opposite sides of the transversal and inside the parallel lines. 5 and 3. 4 and 6. How about 4 and 3? Are they opposite sides and inside? Yeah. Okay. Now, let's name a pair of angles that's opposite sides of the transversal, inside the parallel lines, and at opposite intersections. 4 and 6. Opposite sides, inside the parallel lines, and at opposite intersections, aren't they? Any other pair? 3 and 5. 1 and 7 are not inside the parallel lines. See, if you look at this as being the inside the parallel lines, what's in the box is inside the parallel lines. 3 and 7 are out here. They're not in, I'm sorry, 1 and 7 are outside. Does that make sense? Okay. So there's two pairs of alternate interior angles here. 3 and 5 and 4 and 6. They're opposite sides of transversal, inside the parallel lines, and at opposite intersections. Does that make sense why my definition is the way it is? These definitions only describe what the setting looks like. They actually don't say these lines have to be parallel. They wouldn't have to be parallel. Okay? My lines could look like this. Are M and N parallel lines now? No. They're most definitely going to intersect somewhere in the near future on the left end of the lines, aren't they? Okay? So they're not parallel. But we still have alternate interior angles there. What are they? 4 and 6 and 3 and 5. We still have corresponding angles. What are they? Corresponding. What corresponding mean? Same position. 1 and 5. 2 and 6. 4 and 8. 3 and 7. Good. Okay? Any one of these rules is really simple to get, isn't it? Throw two of them together, now you got to think a little more. And in just a second, we're going to throw a third one in there. Makes you think a little more, yeah. Okay? So let's go down and get the third one. Same side interior angles. We can also write down the definition of transversal, and then we'll talk. Same side interior angles are on the same side of the transversal and inside the parallel lines. Now that we've done a few of these concepts, let's see if you can just go straight to identifying a pair of same side interior angles. Go ahead, Emily. 3 and 6. Any others? Go ahead, Jared. Sorry. 4 and 5. Same side of the transversal, inside the parallel lines. Now again, same with the other two. The lines would not have to be parallel. I could have something that looked like this. I would still have same side interior angles. Okay? Still have same side interior angles. Okay? So any questions on these three concepts? They'll become very, very important as we go through the rest of the semester. Okay? Some things I don't expect that you to remember. These are things I expect you to remember. And then what's special about them, we're about to give you in the form of theorems. Okay? The first one is corresponding angles postulate. Corresponding angles postulate. If the lines are parallel, then corresponding angles are congruent. So if we go back to this picture, we said if these lines are parallel, the marks they use to show parallel would be, I get a marker. Let me do this first. The marks they use to show parallel would be a little arrow on the lines. Okay? That means those lines are parallel. So when you see two lines in the book or on a test and they have those little marks on them, that means you can know those lines are parallel. If they don't have that on there, if they don't say lines L and M are parallel, then you can't make that assumption. If they showed you this, that would mean line N is parallel to line M. Okay? If they showed you that, then you would know that. Or if they put these little marks on here like we have here, then that tells you that they're parallel. So, knowing these lines are parallel, what do we know about corresponding angles? Okay? But remember, even if I move my lines so they're not parallel, they still are in the same position, right? So because of the theorem or the postulate we just copied down, what's true about these lines, or these angles, corresponding angles, because the lines are parallel? Hunter?
2 and 6 are the same.
2 and 6 are the same. So we could say measure of angle 2 is equal to measure of angle 6. Or we could write it, angle 2 is congruent to angle 6. Remember a few days ago I said, let's try to be consistent. We say measures are equal, figures are congruent. So if we say the measures of the angles, we use an equal sign. If we just call it angle, then we use a congruent sign. Okay? Now I told you before, I'm not going to totally beat you up on a test on something like that, but I want you to work hard to try to be consistent. Okay? Measure of angle 2 is equal to measure of angle 6. What else is true because of corresponding angles postulate? Someone other than Hunter. What else is true? What do you think, Megan? Because of the corresponding angles postulate, what other statement could we write?
Is 1 and 5 the same?
1 and 5 would be the same also. Okay? Megan gone. I was talking to Megan Wallace, but that's okay. So you said angle 1 is congruent to angle 5, or you could write that as, that's an or, measure of angle 1 is equal to measure of angle 5. Okay? Megan Wallace, what else could we say because of this postulate? Nice. Measure of angle 4 is equal to measure of angle 8. Are there any others we could write, Hunter?
2 and 8, or the measure of angle 2 and the measure of angle 8 are equal.
Yeah, not because of this postulate though.
Well, you go.
Not because
2
of
and
this
6.
postulate though. We're only talking about this postulate. I'm not going to deny what you're saying is true, but it's not this postulate, okay?
Okay.
We can write a proof and show everybody that you're right, but right now I just want to stick to this postulate,
Well,
okay?
wouldn't it be the postulate because 2 and 6 are equal, and then you just find the vertical equality with that?
So you're saying, but we've already made that statement.
Yeah, so then you find.
Right. I'm not saying we can't prove it, Hunter, you're right, but it's not this postulate. It takes another step. Actually, it might take 2 more steps. Okay? It would. It'd take 2 more steps. Okay?
Okay.
So just with this postulate, you're right on. And that's going to be a homework question to do exactly what you're talking about. Brandon, what's the next one? The last one.
Angle 3 is congruent to angle 7.
Angle 3 is congruent to angle 7. That's correct. Angle 3 is congruent to angle 7. And I really appreciate the last two, all 3 of you that volunteered, said it correctly. You used congruent with the angles properly, or you used equal with the measure properly. So good job. Let me clean this up so we can talk about the next one. I don't mean to cut you short, Hunter, but I didn't want to confuse anybody at this point about what you're talking about. You're exactly right on the statement you're trying to make. Okay, let's go back to here, and let's write down the theorem for AIA. What's AIA stand for? Alternate interior angles, that's correct. And it's acceptable to write AIA. Most textbooks will write it as AIA after they've written it down as alternate interior angles. So if lines are parallel, then alternate interior angles are congruent. Alright, if we go back, name a pair of alternate interior angles for me, Brad.
Angle 3, angle 5 are congruent.
Angle 3 and angle 5, and because of this theorem, they're what?
Congruent.
They're congruent. So we would say angle 3, with a marker, angle 3 is congruent to angle 5. Or, there's one other pair. Rebecca, would you tell me the other pair, please? Angle 4 and 6. So what could I write then? That's correct. Or someone else might have written, Rebecca, can you tell me what someone else might have written instead of congruent? They might have used equal and written what? The measure of no, just these, there's only two. Yep, alternate interior, there's only two pair. So would you write the whole, or say the whole statement for me? Measure of angle 3 equals measure of angle 5. There you go. Good. Okay? Alright. I forgot to move this away from my computer. I hope it's at least picking up my voice okay. The computer fan makes a noise. So anyway, only two pair of alternate interior angles, and you can write it either way. Alright, now last one. Same side interior angles theorem. I'm going to ask you to predict what do you think is going to be true about these. Let's draw a little picture of them here. Same side interior would be like 1 and 2. Well, excuse me. Adjacent, they do share a common side, that little segment between the lines, but they don't share a common vertex. But that's encouraging that you're using that term like that. That's a good thing. Okay? But remember, adjacent, they have to share a side and the vertex. So those aren't adjacent. They are next to each other. In a polygon, when they're next to each other, we call them consecutive. And we might think of it in terms that way. Do they look equal to each other? No, they're not. What do you think, Hunter?
If you add the two angles together, they're equal to 180.
They are. And what term is that when you add two together and they add up to 180? Supplementary.
Oh.
Okay? So if the lines are parallel, then same side interior angles are supplementary. Good job. Now, this last little note I have here, two column proofs always look like this. I've shown you this before, but if you didn't write it down, you should write it down now. They always are in this form, two column. On the left we put statements, on the right we put reasons or justifications, you can call them whatever you want. Okay? Some textbooks might call these the hypothesis and those the conclusions, like in a conditional. The hypothesis is the statement you make, the conclusion is what, how do you know that was true? Okay? So multi-column proofs always look like that. Here's a picture, I think it's similar to the one in the book. Let me grab my book. Okay, the first two problems in the textbook have a picture like this, and it's very confusing for people. So I wanted to look at it together with you. Number 2 says angles 1 and 4. Angle 1, angle 4. The directions say, name the two lines and the transversal that make up angle 1 and angle 4. And so, if you think of it this way, what two lines may or may not be parallel, but you can think of them as parallel lines if you want, and then what transversal create angles 1 and angle 4. So that's what the question's asking. So here's angle 1, here's angle 4. What two lines and what transversal create those two angles? Now my lines are not parallel, but what two lines do we have there? That appear to be parallel, they're not really, but. Okay. Sadie's saying these two appear to be parallel, and these two appear to be parallel. Okay. Can you name this top line for me? How do we name that? Anybody? Go ahead, Hunter.
Segment PQ.
Okay. Since we're talking about a line, we're going to use a line symbol. And so we're going to say line PQ. Someone other than Hunter, how do we name this other line then? Line SR. Okay. How would I name this line? Line QR. Someone totally new now. How would I name this other line over here? Line PS. Have we named all the lines in the picture? No? Right, Jeffrey? You have one more to go? So what's our last line we need to name? So name it. Line SQ. I agree with that. Line SQ. Okay? Now, let's go back to the question. Jackson, you ready to answer it for me? Looking at these two angles, angle 1 and angle 4, what two lines and what transversal do we have to use to make those two angles?
Line QR, line PS, and line SQ.
Good. Line QR, I'm going to get the highlighter out. Line QR is this one. Line PS was this one. I hope you said there. I wasn't sure which your second one. And then what transversal?
SQ.
Line SQ. Let's use a different color for that. So there's our transversal. Okay? Is anybody confused on how those three lines together make up those two angles? Because they're going to ask you questions like that in the first couple. Maybe three. All right?
Mr. Mitchell,
Yep.
for that, could it be PQ and SR?
PQ.
Oh wait, no, that'd be 2 and 3. Never mind.
Right. Okay? All right. Today's assignment then. I'm not gonna beat you up with numbers. There's only gonna be 13 questions. Lesson 3-1, 1 through 25 odd. Okay? Lesson 3-1, 1 through 25 odd.